Hello everyone. Welcome to webinar series on Intel Higher Education Challenge 2017. Today we will discuss analog and digital sensor interfacing with Intel Edison development board. Here are the lessons we are going to learn today. Firstly, we will discuss about sensors, their classification and why sensors are needed. Then we will discuss about GPIOs of Intel Edison Arduino breakout board. We'll also discuss switches and jumpers available on Intel Edison Arduino breakout board and their functions. Next, we will talk about some important Arduino APIs required for analog and digital sensor interfacing. We will also discuss how to control the brightness of LED light based upon light sensor. We'll need following hardware components for today's webinar: one micro USB cable, one 12-volt DC adapter, and a personal computer running Windows, Linux, or a Mac operating system, and Arduino IDE installed on the computer. When we talk about sensors, the very first question is, what is a sensor? So sensor is a device which converts physical signal into electrical signal. For example, temperature sensor, humidity sensor and smoke sensor, etc. Based on the type of electrical signal a sensor generates. Sensors are classified in two types: analog sensors and digital sensors, or on the basis of the physical signal it processes. For example, pressure sensor for pressure, light sensor for light, smoke sensor to detect smoke, etc. Now next question is, why do we need a sensor? Sensors are used to collect the data from physical world, and the data could be used for multiple applications like for automation of devices, example fully automatic washing machine or air condition. Data could also be used for analysis purpose. For example, analysis of temperature variations in a location, and we can take corrective actions to control the temperature variations in that particular location. So let's talk about the GPIOs of Intel Edison. Intel Edison Arduino breakout board got total 20 general purpose input output pins, out of which 14 are digital pins and 6 are analog pins that are used to connect analog sensors. Out of these 14 digital pins, 6 could be used for PWM signal generation. The default resolution of PWM pin is 8-bit and analog pin is 10-bit. Intel Edison also got a ICSP header that is called in-circuit serial programming, that is SPI, one I2C header that is called inter-integrated circuits, and UART available on D0 and D1 pins. This UART available at D0 and D1 pin is available for user for external sensor interfacing. One USB host port to connect camera, mouse, etc. One USB client port that is UART based and used to upload Arduino Sketch, also to power up board using USB. A mechanical switch located in between USB host port and USB client port, that is to control whether to make or operate board in device mode or in host mode. So if we keep this mechanical switch towards USB client port, the board will be acting as a device, while if we keep this switch towards host port, the board will be acting in a host mode. Now next to micro USB port is for serial communication and also Ethernet over USB. Other than GPIOs and hardware protocols, Intel Edison Arduino breakout board also got some switches, jumpers and headers. So one jumper is IO reference jumper that allows selecting between two voltages, 5 volt or 3.3 volt. Another one is A reference, analog reference. Header allows selecting ADC voltage reference. NTC header allows setting NTC thermistor input used to monitor battery temperature while charging the battery. ICSP same SPI header. Battery header allows attaching a lithium ion battery for low power applications. Make sure the battery is attached with the correct polarity. Another is the PWM jumpers J11 and J12. The PWM headers allow the 4 PWM sources from Intel Edison board to be configured to drive 4 of 6 Arduino PWM pins. Each Edison PWM pin can be jumpered to one of 3 Arduino PWMs. Next is the switches. And switches on Arduino breakout board for Intel Edison are shield reset button SW1 U1. The shield reset will reset the sketch stored in Intel Edison board. Then we have power button. Pressing and holding the power button will cause the Intel Edison board to power down. While if we talk about FM button, FM it to recover the board. RM button, also called RCVR mode, is used to recover Intel Edison board that has a corrupted software image. During boot, the state of RM button will cause Intel Edison board enter into two different recovery modes. During boot, when the FM button is pressed high and the RM button is not pressed, which is again high state, the processor attempts to load the firmware from flash from the location specified in UMIP header. During boot, if the FM is pressed high state and RM button is pressed low state, the processor attempts to download from USB type B port, regardless of the UMIP header. Reset button, the reset button is the master reset, which will reset the board as well as the module. Now let's talk about sensor interfacing. So interfacing sensors with board using GPIOs, we can refer the given link for the list of industrial sensors and UPM libraries supported sensor list. Today we will write a Arduino sketch to read analog and digital sensors. Let's discuss some of the basic and important Arduino APIs and their functions. So one Arduino API is pin mode, which is to set a digital pin in input mode or in output mode. Another API is analog read, which is to read the analog sensor value, where it takes single argument, that is the pin number. Another API is analog write. This is used to generate a PWM signal, where you need to specify the PWM pin, any of the pin 3, 5, 6, 9, 10, 11, and the value you want to write. So if PWM, the default resolution is 8-bit, the maximum value we can write is 255 and minimum we can write is 0. So when we are writing 0, it is generating a 0% duty cycle PWM signal, and if we are writing 255, it will generate 100% duty cycle PWM signal. Then API digital read to read the digital pin, digital write to write on the digital pin. It takes two argument, pin number and the state, low or high. Next API is serial.begin, that is to set the baud rate of UART. Serial.print, print something on the serial monitor. Serial1.begin, setting the baud rate of UART1, which is available on 0 and 1 pin or D0 and D1 pin. Delay to generate the time delay. For more Arduino APIs, you can refer the following link. In this example, we are interfacing analog temperature sensor with Intel Edison board. Analog temperature sensor converts temperature into the voltage. The output voltage of temperature sensor varies with respect to variations in the input temperature. Analog temperature sensor got 3 pins or 3 wires, red, black and blue. Red wire to be connected with 5 volt, black wire is to be connected with the ground, while blue wire is a signal wire that is to be connected with one of the analog pins. So total 6 analog pins are there, A0 to A5. So output of analog temperature sensor is voltage, while processor understands values of zeros and ones. So we need to convert this voltage signal into the digital signal. For that we require ADC. Intel Edison got on board ADC, which converts output voltage of temperature sensor into the digital zeros and ones. So if we talk about the resolution of ADC, it is 10-bit. So output of ADC a number between 0 to 1023. So basically our concern is not this value 0 to 1023. Our concern is temperature in degree Celsius. So how we can get temperature from the values of 0 to 2, 3. So we can convert first these values into the voltage, and once we have the voltage, we can use the sensitivity, and sensitivity of LM35 is 10 millivolt per degree Celsius. So if we have variations in temperature, we can get output in temperature by simply using the sensitivity of temperature sensor. So this is how we need to connect a analog sensor with Intel Edison board. So you can clearly see red wire is connected with 5 volt, black wire is connected with the ground, and blue wire is connected with the analog pin. Here I have connected with A0. Similarly, when we talk about digital sensor also got 3 pins: red, black and green. Red is again 5 volt, black is again ground, and green is signal wire that is to be connected with one of the digital pins, while output of digital sensor will always either 0 or 1. So in this example we have a digital touch sensor. It will generate a high signal. If we will not touch it, it will generate a low signal. So high and low means 1 or 0. API to read the digital value is digital read. So this is how we need to connect the digital sensor. So here we can say red wire is connected with 5 volt only, black is connected with the ground, while signal wire, that is green in case of digital sensor, is connected with the one of the digital pin. So I have connected with pin number 3. The next question is, if you want to interface multiple sensors with Intel Edison board. Intel Edison board got limited VCC pin and limited ground pin, and when we are talking about interfacing more than one sensor, each sensor will require separate 5 volt signal and separate ground. So we need to have common ground and common VCC. So we can use breadboard to take common 5 volt and common ground, while both the sensors VCC and ground pins could be connected with the breadboard, and signal pins to be connected with the digital or analog pins of Edison board, depends upon the type of sensor. So in this example, we are controlling brightness of LED on the basis of ambient light sensor output. So I have written a program where I'm using analog read API to read the analog pin. I'm using map API to convert a number from one range to another range. I'm using analog write API to write or generate the PWM signal, and these are the values that I'm displaying on serial monitor. For further information, please contact mentor@fic.in. Thank you so much. Have a nice day.